Hello, all, and thank you for joining us today for the screening and dedusting webinar. We're going to give everyone a couple more minutes to join us, so please bear with us, and we'll start in about 2 minutes. Okay, we have a good amount of people joining us, so thank you again. Hello, and welcome to the screening and dedusting webinar. We're pleased to have Rob Voorhees, President of Hasakawa Custom Processing Services, as today's presenter. Before we begin, a few housekeeping items. Today's webinar will be recorded and made available on the Hasakawa Custom Processing Services website following the event. Please feel free to submit your questions at any time using the Q&A chat box. We'll address questions at the end of the presentation. If we're unable to get to all questions due to time constraints, we will be sure to follow up via email. And with that, I'll turn it over to Rob to get us started.
Good afternoon, and welcome to our presentation on the processing services offered by Hasakawa Micron. My name is Rob Voorhees, and I will be your presenter today. Today's presentation will be focused on the screening and dedusting services that we can provide. Hasakawa Custom Processing Services made a major investment in a new facility dedicated to providing our customers with state-of-the-art processing services. In 2021, we initiated a search to find a new location for our processing business. After an extended search throughout several states, we settled on a site in Goldsboro, North Carolina. This is a view of our brand new facility in Goldsboro, which started full-scale processing services in April of 2024. In the presentation, I may refer to the company as HCPS. The new facility is uniquely suited for our processing business. This 50,000 square foot building sits on 19 acres of land in the Park East Industrial Park located in Goldsboro. We relocated several processing systems from our plant in New Jersey, and we made substantial investments in new equipment to expand our processing capabilities. The major portion of the facility space is dedicated to various processing systems, warehouse space, and future systems installation. We now have 11 installed systems available to our customers for a variety of processing services. This is a partial view of the processing area at Hasakawa Custom Processing Services. In the foreground are 3 systems for size reduction and micronization. Further in the background are additional systems providing size reduction, blending, and screening operations. A separate area is dedicated to recycling and granulation. Each installed system has its own nuisance dust collection points at various locations to ensure a dust-free and clean processing environment. All systems are designed for processing high KST value materials, and each system is protected by a suppression system designed to prevent dust explosions related to the processing of organic materials or other chemicals that are potential hazards. The Goldsboro, North Carolina location was chosen for several reasons. However, the most important was the access for our customers. Over the last decade, the southeast sector of the United States has had the largest growth in the country for companies establishing new businesses and manufacturing facilities. In addition, many companies have relocated to the southeast, and in particular North and South Carolina, due to the many benefits and quality of life opportunities these states have to offer. Principal among them is a strong labor force and an overall lower cost to do business. Hosokawa Custom Processing Services is strategically located in close proximity to the major north-south corridor of Interstate I-95. We are also 1 hour from Raleigh International Airport with access to domestic and international destinations. And the major seaport of Wilmington, North Carolina is 90 miles to the southeast of our Goldsboro location for the importation or export of materials from our international customers. HCPS offers a range of services for processing of chemical, mineral, polymer, and plastic materials. The services we offer include several different types of size reduction technologies, screening, mixing, blending, compaction, packaging, particle size analysis, and particle characteristics analysis. We conduct feasibility testing to ensure we can meet the specifications, quality, and quantity of the finished product you require. And when customers are ready to commit to large-scale orders, we then process the materials at our Goldsboro facility. John McGovern is the manager of the business and has over 35 years of experience in the industry. We have a staff of 14 technicians and 2 maintenance personnel, and we currently operate 2 shifts, 5 and 6 days a week. Our services are focused on processing materials for the chemical, mineral, and polymer industries. With multiple systems, we have many processing options and the ability to handle materials with many different characteristics. With both pilot scale and large scale systems, we can accommodate all quantities of materials. However, our services offer the best economic efficiency when handling projects in the 10,000 to 100,000 pound range per processing run. For the next half hour or so, we'll cover the basics of dry powder separation by screening and dedusting. We will talk about different types of classifying devices and their application that we can provide at HCPS. And we will look at how screening and dedusting are used as part of a powder processing system. Separation of materials is not a new concept. Various forms of classification and separation have been in existence for thousands of years. Separation technology has been used to improve product yields and quality. From the early removal of husks and chaff from grains to the separation of heavy metals, man is using basic principles of density, airflow, and mechanical means to accomplish the separation of materials. Significant developments in equipment and machine design over the last 100 years have allowed for the improvement of separating and classifying of powders. The end result has been to improve the ability to control the desired separation point, or as we call it, the cut point, and to optimize the yields of the coarse and fines fractions. Equally as important is the ability to produce high-quality products on a repetitive basis. Classification is the process of separating or dividing a given material into multiple fractions, quantified by a distinguishable property, the most common property being particle size, where we separate larger particles from smaller particles. Another property would be density, separating heavier particles from lighter ones. Particle shape is yet another property for separation. As an example, separation of spherical particles from plate-like particles. Unfortunately, separation by shape is normally very difficult to accomplish. Most commonly, the fines fraction is usually the end product and the coarse fraction is discarded, or as an example, the coarse fraction from a milling operation could be returned to a mill for further size reduction. And there are some applications where the end goal is to dedust the product. In this case, the coarse fraction is the end product and the fines are discarded. There are numerous methods available for classifying dry powders, so we'll begin by categorizing these methods by equipment type. Mechanical sieves can be used in various styles to screen or sieve powders through perforated or woven screen sheets with different opening sizes. Crude separation of powders can also be accomplished with cyclones. This is a good solution when only fine particles are to be removed. Gravity classifiers use gravitational force, weight, to create a force on heavier particles, separating them from lighter particles that are more susceptible to the force created by counter airflow. Separation by gravity can be accomplished for cut sizes in the 200 micron range up to several millimeters. Above 150 microns or 100 mesh, mechanical screeners are usually the most efficient and cost-effective method for dry powder separation. For cut sizes of 100 microns down to 1 micron, dynamic air classifiers are required. Dynamic classifiers use the centrifugal force developed by rotating classifier wheel to oppose the centripetal force created by the opposing airflow to separate particles. At the moment, HCPS does not offer dynamic air classification. Let's start with a discussion on mechanical separators. The mechanical separator works via mechanical screening or sifting technique. This technology uses a wire mesh screen with different opening sizes to separate a given product into 2 or more fractions. HCPS offers screening technology like the gyratory type screener that is pictured in the slide. It can be outfitted with multiple decks with different screen sizes in each deck, starting from the top with coarse screens to the bottom with finer screen. This configuration will allow the incoming feed material to be separated into multiple fractions from coarse to fine. These units are particularly suitable to classify free-flowing powders with a low angle of repose. A range of screening motions and amplitudes can be applied to effectively move the material over the screen surface. Depending on the placement of the imbalanced load on the screener, different types of motions can be created. These devices usually can operate with 90 to 95% efficiency, which makes them very attractive options for many applications. One of the problems associated with this type of classification device can be the blinding of the screens. We can provide screening cleaning devices under the screen to cause additional impact from the bottom to dislodge particles and keep the screens clean and make the screening process more efficient. There are a couple of terms worth mentioning when discussing screening in general. The first term is scalping. Scalping means the removal of a small percentage of coarse material that could be in the feed material. The second term is dedusting. Dedusting is just the opposite. It means that a small percentage of fine material is the undesired fraction that needs to be removed from the feed material. This slide shows a typical mechanical screening system. Feed product is uniformly introduced to the screener through a centrally located product inlet from a volumetric feeder. In this case, the screener has one screen which provides for the separation of powder into 2 fractions. Here, the coarse fraction is shown discharging from above the screen to a drum on the left, and the fines fraction is discharged from the bottom of the screener to a drum on the right. Mechanical screening systems like this are most efficient for separations above 100 microns. In some cases, it can process finer materials that have very good free-flowing properties. The separation principle at work in this device, called a cyclone, is what is known as a free vortex classification. The feed enters the housing tangentially in a high-velocity airstream, typically in the range of 30 meters per second, as shown here by the red arrow. The air is then put into a spiral motion and continues downward due to the location of the center outlet or fines discharge tube in the cyclone. The circular airflow movement forces larger particles to the periphery of the housing and then down to the coarse outlet at the bottom of the cyclone. The airflow draws the finer particles inward towards the fines outlet. By varying airflow, air velocity, and cyclone dimensions, cut size and collection efficiency can be maximized to a certain extent. These devices are very efficient in collecting particles that are larger than 10 microns. Their efficiency starts falling off as the particle size gets smaller. The major problem with cyclones is their inability to control the cut point. This being a simple device with no moving parts results in it being a very economical solution for some applications. This device can also be used as a primary collection device due to the same beneficial features mentioned earlier. This graph shows a collection efficiency curve for a typical high efficiency cyclone. It can be seen very clearly that above 10 microns, the collection efficiency is well above 95%. Cyclones are typically used in granulator or milling systems where the end material is coarse enough for the cyclone to separate material with a very high efficiency. Cyclones are used in milling systems to remove a small amount of fine material from the feed and eliminate the dust collector in being the primary material collection device. This slide shows a simple size reduction system where coarse material is discharged from a rotary granulator and then air conveyed to a cyclone for product collection. In this case, the collection efficiency of the cyclone is very high, eliminating the requirement for a dust collector for fine material collection. The minimal amount of fine material that passes through the cyclone is easily collected in filters shown here on the discharge of a material handling fan. The low dust loading requires only periodic emptying of the filters. These types of milling systems are suitable for grinding a wide range of materials with a Mohs hardness of up to 4. The principal operation of these air classifying mills consists of mechanical impact of material by high-speed rotating hammers. Particles are air conveyed into the mill for size reduction, and the internal classification system retains the particles in the mill until they reach a defined top size, which is determined by the rotational speed of the classifier wheel. In this case, milled material is then air conveyed to a cyclone where secondary classification takes place. In this system design, the majority of end product material is separated out by the cyclone, and the remaining fines are then collected in a dust collector. In this case, the collection efficiency of the cyclone is very high, eliminating the requirement for the dust collector to be the primary collection device for the fines, as dust loading is very low. The gravity air classifier system shown here is based almost entirely upon the principle of elutriation. It has a zigzag-shaped classifying channel to improve classification. Air enters at the bottom of the classifier, and the feed enters near the top. The air carries the fines upward against gravity and out the top of the classifier, and the coarse particles drop by gravity and exit the bottom of the classifier. This type of classifier provides gross classification in the size range that can also be accomplished by sieving, but also works for materials that cannot be effectively sieved. This type of system can also be effectively used to dedust products such as plastic granules, fibrous materials, and separation of leaves, sticks, and bark from spices and other dissimilar density materials. These types of classifiers are capable of separations in the 0.3 to 10 millimeter size range. Here's a closer look at a classifier that works on the elutriation principle. This type of classifier works well when the requirement is to classify materials based on their difference in bulk density. The internal zigzag profile of an elutriation classifier offers several advantages. The particles that slip down along the walls become caught up again in the upward airflow at every turn of the channel. The zigzag classifier can therefore be regarded as a device with many separation zones. This gives the classifier a high separation efficiency in its operational range. The unit pictured here is fed closer to the bottom of the classifier, and the coarse material gravitates downward against the flow of air, and the fines are conveyed upwards and are collected in a cyclone. The typical load factor for a zigzag classifier is in the range of 1 kilogram of material per 1 kilogram of air. Installed at our processing facility in North Carolina, we have a complete system for granulation, product collection, and dedusting as shown here. The product to be processed is fed into our 1646 heavy-duty granulator shown here on the far right. The granulated product is air conveyed to a cyclone where the product is collected and discharged to a deduster located at this discharge of the cyclone. The fines removed by the deduster is air conveyed and collected by a smaller cyclone located at the left of the picture. This system is designed to be a continuous process to produce clean, reground materials. Let's take a look at this type of equipment in action. You'll see is a granulated plastic material conveyed to a cyclone where it is collected and discharged into a dedusting classifier, where light density paper material is separated from the plastic, leaving a clear reground material that can be recycled. Let's take a look. This concludes our presentation today on dry powder screening and dedusting. HCP offers screening and dedusting services along with milling systems that can incorporate cyclones for initial product separation and gravity classifiers to address the separation of materials with differences in density or materials that require dedusting. Please feel free to contact us and make it to tour our facility in Goldsboro, North Carolina. Thank you for your time today and your interest in Hosokawa Custom Processing Services.
All right, thank you, Rob, and thank you everyone for joining us. We only have a couple questions, so I'll get to those. Rob, someone asked, outside of screening and digesting, what else can be done at Hosokawa Custom Processing Services?
So, other than classification services, I think you're asking about. So, we have multiple size reduction systems. We have jet milling for ultra fine size reduction. We have air classifying mills for a wide range of applications. We have hammer mills for coarse milling. We have attrition mills for grinding heat sensitive and hard to grind plastics. Um, we also offer blending services. We have several types of blenders to use to make homogeneous end products. We have a complete analytical lab for particle size analysis. We do both bulk packaging in bulk bags, drums, or bags for shipment of processed material. So we offer a wide range of capabilities. You saw the granulation system there, so we can do coarse granulation. We also offer compaction if it's required. So I think earlier on in the slides, I mentioned all the operations that we can offer.
And someone else asked, are part one and part two available for viewing? I can answer that if that's okay, Rob. Yes, they are available for viewing. You can find that on our website. There will be an email that's sent out thanking everyone with a link to the recording. So all you have to do is follow that link and you'll find part one and part two. Another question, is there a separate webinar about your fine powder grinding and separation capabilities below 100 micron particle sizes?
Yes, we already did one presentation on that. It's also on our website. And actually on April 8th, we're going to do another webinar on air classification milling. And those typical mills can grind down to a top size of about 20 microns. If you're looking for 10 microns or finer, that most likely refers to our jet milling systems. There is some information on our website about our jet milling systems. But in the future, we'll probably do a dedicated webinar just for jet milling applications.
Okay. And I believe that are all the questions. Oh, here's one more. Does Hasakawa offer dedusting of fine raw materials, for example, via spraying the powder in a rotary or pin mixer?
Yes, if you shipped us the material that's already been dried or blended, then we can separate it through our dedusting system that you saw in the video. The material
And
just would not go through a granulator first.
do we have experience with needle coke processing?
What was the question again, Leah?
Do we have experience with needle coke processing?
I don't believe we do, although we've had experience with grinding materials that have a needle-like particle shape, and those are very difficult to separate because of the shape. It's not a the needle type shape can go through a perforated opening in one direction, but not the other direction, if you understand what I'm saying. So needle-like particles are extremely difficult to separate if that's what you're looking to do.
Okay, and I believe that is all the questions that we have time for today. Oh, we'll take one more, I'm sorry. And this will be the last question. Does Hasakawa have any experience in processing chromium metal?
I believe we probably have. We do tungsten carbide quite a bit on our jet milling system. So, if you send a separate email to me, I can answer you. I'll take a look at our database and see specifically if we've processed that material in the past.
Okay. Thank you, everyone, for joining us today. Everyone who participated and signed up, you will be receiving an email with us to a link to the video. So if you have any other questions, please feel free to reach out to us. Thank you again.